Hello, and in this tutorial I am going to discuss about characteristics of periods. There will be two tutorials on this. Okay, first let us discuss about few characteristics, starting with valence electrons, which is nothing but outermost electrons. Now let us go to some drawing which I have drawn for you. Let me pull this drawing. Now I have drawn period 3, which starts with sodium and ends with argon. Now electronic configuration of sodium is 281. That means the first orbit is having 2 electrons, second one is having 8 electrons, and the third orbit is having 1 electron. So the second element, magnesium, is having 282. That means the last orbit is having 2 electrons, like aluminum 283. That means as we move along, the atomic number increases by 1 and the number of electrons in the outermost shell is also increasing by 1. I forgot to write the atomic number of phosphorus, which is 15, for sulfur it is 16, for chlorine it is 17, and for argon it is 18. So as you can see, the electronic configuration starting from 281 all the way up to 288. For argon, the number of electrons in the outermost shell is 8. That means it has already completed the octet, because that is the ultimate goal of every element. If it can reach the octet, then it is stable. As long as its octet is not achieved, that means it does not have 8 electrons in the outermost shell, it will try to enter into chemical reaction, sometimes by gaining electrons, sometimes by giving electrons, and sometimes by sharing electrons, so that it can have a filling of octet, or it can have octet. Now number of valence electrons, for sodium it is 1, for magnesium it is 2, and all the way up to argon, for which the valence electrons is 8, which has already completed the octet, so it will not enter into chemical reaction. Therefore the valency of sodium is 1, for magnesium it is 2, for aluminum it is 3, for silicon it is 4, for phosphorus it is again 3, it is not 5. The reason is phosphorus is having 5 electrons, so it will not be able to give up 5 electrons. Giving up 5 electrons is very difficult, because then it will have 5 extra positive charge. So it will try to acquire 3 electrons by means of sharing, by means of covalency, to complete the octet. So it will try to acquire by means of sharing. So that's why phosphorus is having a valency of 3 and not 5. Of course there are some compounds like phosphorus pentoxide, P2O5, which is a covalent compound, which we can say the valency is 5, but that is not electrovalency. Okay, so let me draw it here, probably it will be easier. For example, in the case of sodium has only 1 electron in the valence shell or outermost shell, so it will try to give 1 electron, it will try to donate 1 electron to form an octet. So for example, it will give 1 electron to chlorine to form sodium chloride. Whereas phosphorus, which is having 5 electrons, so it will try to acquire 3 electrons by means of covalency to form an octet. So goal is to form an octet either by giving electrons, or by taking electrons, or by sharing electrons. Similarly for sulfur, which already has 6 electrons in the outermost shell, so it will acquire 2 electrons by means of covalency to form octet. For chlorine, it has 7 electrons, so it will be easier for it to gain 1 electron to form octet. For argon, it has already reached octet, it has already reached its destination, its goal, final goal, so it will never enter into chemical reaction. So they are inert gases. Helium, neon, argon, they are all inert gases. Now let us talk about atomic radius, which is a periodic property. Atomic radius, as we move along the period, it keep on reducing. So atomic radius of sodium is bigger than atomic radius of magnesium, which is bigger than aluminum, which is bigger than silicon. Now atomic radius of argon is sodium is 186. For magnesium it is 160. I'm sorry, by mistake I said argon. Atomic radius of sodium is 186. For magnesium it is 160, and all the way down to argon, for which it is 71, which is the lowest in the period. And always atomic radius will be lowest for the last element in the period, that is lowest for the inert gas element. So as we move from left to right in the period, the atomic radius decreases. Now let me ask one question. Why the valency of chlorine is not 7? That is the same as the number of valence electrons, but it is 1. The reason is chlorine, which has 7 electrons in the outermost shell, it will, if it has to exhibit a valency of 7, that means it has to give up 7 electrons, which is very difficult, which is not possible. So chlorine will try to acquire 1 electron to form to reach the octet. That's why chlorine having 7 valence electrons will exhibit or will show a valency of 1 and not 7. Whereas in case of magnesium, which is having 2 electrons in the outermost shell, which will try to give up 2 electrons, to donate 2 electrons to reach octet. That means it will come to the one shell down, one shell lower, where it will have the octet. So magnesium will give up 2 electrons. So this is giving up electrons is called positive electrovalency, and acquiring electrons is called negative valency. So that is the reason. So chlorine having 7 electrons will try to acquire 1 electron and show a valency of 1.